Here's Yuchen's video assignment of modeling a roller coaster, Steel Dragon 2000. I will analyze the characteristic and the property of the functions. Here's an overview of 3 parts that I will be analyzing. And the given height of the first hill is 97 meters in real life, and I measure as 10 centimeters. And the second hill is 76.8 meters, and I measure as 7.917 centimeters. Therefore, the converting ratio is 10 centimeters equals to 97 meters in real life, and this is applicable for both height and distance. I used the logistic function to model the first section of the roller coaster, and here's the equation.
Y equals to 97 over 1 plus 1.10749 times 0.01138 times the power of 0.02 times x minus 40 plus 3.5. And then the characteristic of this function is x belongs to a real number and 0 is smaller and equal to x and smaller equal to 90. And the range is y belongs to a real number and 4.487 smaller equal to y and smaller equal to 97.595. And there's no x-intercept, and then there is a y-intercept at 0 and 97.595, and there's 2 horizontal asymptotes. One is at 105 meters, one is at 3.5 meters, which is here and here. And then there's no holes, and if there's no restrictions, the end behavior will be as x approaching to positive infinity, and y will approach 3.5, which is the horizontal asymptote. Another one is x to approach to negative infinity, and y is approaching to 105 meters, the other horizontal asymptote. But here, since we have a restrictions, then there will be no end behaviors. And the interval for f greater than 0 or f smaller than 0. All intervals are f greater than 0 because it's above the ground. And then the interval rate of change slope. So from 0 to 45 meters, there is like concave down, so that's decreasing slope. And from 45 to 90, here have a increasing slope since there's a concave up. And there's no max and min since there's a restrictions. And then the a value is 0.011389. That's a vertical compression by a factor of 0.011389. And the k value is negative 0.02, which is negative 1 over 50. So that is reflect over y-axis and horizontal stretch by a factor of 50. And b value is 40, and that's a horizontal shift to the right by 40 meters. And the c value is 3.5. That's a vertical shift up by 3.5 meters. And here is how I got the a value and base and the x and this part. And here's, you can take a look. And the reason I flipped this graph to this way is because the roller coaster actually go this way. Here's the second section of the roller coaster. I'm using a polynomial quartic function to model this. So the function is y equals to 0.00007 times x minus 60 times x minus 140 power of 2 times x minus 220 plus 75. So the domain is x belongs to real number and 75 smaller and equal to x and smaller equals to 215. And the range is y belongs to real number and 3.32 is smaller and equal to y and smaller and equal to 75 meters. And there will be no x-intercept and y-intercept. And this is an even degree function because it's a quartic function. And it's neither even or odd functions. And they don't have a line symmetry at y-axis. And f of negative x is not equal to negative f of x. And end behavior. It actually don't have a end behavior since there's a restrictions on domain and range. But if there's no restrictions on domain and range, there will be like the end behavior will be x approaching to positive infinity, and y is also going to approach to positive infinity. And if x is approaching to negative infinity, but y is still going to approach to positive infinity. And interval of f is greater than 0 or f is smaller than 0. So all intervals is f greater than 0 because it's above the ground. And the interval of rate of change. So for this section, like this interval is 75 to 88.3 meters, and it have a concave up, so that's increasing slope. And from this section, like 88.43 to 140 meters, that's like a concave down, so that's decreasing slope. And for this section, that is 140 meter to 196.569 meters, that's a concave down, so decreasing slope. And the last interval is 196.569 to 215. meters, and that have a concave up increasing slope. So the maximum point is over here, 140 meters and 75 meters of distance. And the minimum point is 83.43 and 3.2 meters, which is this point. And the other one is 96.569 and 3.32. And the transformation for this function, so the a value is this, 0.00007, and that is a vertical compression by a factor of 0.00007. And the c value is 75. That means vertical shift upwards by 75 meters. And that's it for this polynomial function. So here's the last section of the graph, and the scale is 10 centimeter on this graph, represent like 97 meter in real life. And then here's the thing we're analyzing, and the period of this on the scale is 4. That means is 38.8 meter in real life. And the height of this is 2.4 on the scale, so that is 23.28 meter in real life. And here is 15.52 meter in real life, and this is 0.8, which is 7.76 meter in real life. And then, so we're using the combination of cosine and the linear functions. So h of x equals to g of x times f of x. G of x equals negative 0.5 times cos 2 pi over 38.8 times x minus 19.4 and plus 0.5. And f of x is negative 0.2x plus 23.28. And g of x is the domain of g of x is x belongs to a real number, x smaller and equal to x, smaller equal to 97. And range is y belongs to a real number, and 0 is smaller and equal to y, and smaller equal to 1. And x-intercept is 19.4 and 0, 58.20 and 97, 0. The y-intercept is 0 and 1. And then there's no asymptotes, there's no behaviors, so an equation of axis is max plus min over 2, which is 0.5, and amplitude is max minus min over 2, which is 0.5. And the period of this is 38.8, because on the scale of this, the max to the max is like 4 centimeters, so that's 38.4 meter in real life. And the interval of f greater than 0, all intervals are greater than 0, and the interval rate of change is 0 to 19.4, and the 38.8 to 58.2, and 77.6 to 97, and all these three intervals are concave down, so that's decreasing slope, and 19.4 and 38.8 and 58.2 to 77.6 meters, that's concave up, that's increasing slope. And the maximum point is 0 and 1, and 38 and 1, and 77 and 1, and the minimum is 19.4 and 0, and 58.2 and 0. The transformation is negative 0.5, that means reflect over x-axis, and there's a vertical compression by the factor of 0.5. And the k is 2 pi over period for cosine, so that's 2 pi over 38.8 meters, that's 0.1618. So that's a horizontal stretch by a factor of 38.8 over 2 pi, and the d value is 19.4, and there's a horizontal shift to the right by 19.4 meters, and the c is 0.5, that's a vertical shift up by 0.5 meters. And then here the h of x, which is the combination of two functions, that's like the domain is x belongs to a real number, and the x 0 is smaller and equal to x, and smaller equal to 97, and the range is y belongs to a real number, 0 is smaller and equal to y, and smaller equal to 23.8 meters, and the y-intercept is same as the other one, and the y-intercept is 0 and 23.28, and the period is the same, and the interval is greater than 0, interval f is greater than 0, and the interval rate of change the same, and the maximum point is 0, 23.28, and the minimum is 19.4 and 0, and 50.20 and 97.0.